Hello everyone. Last class we discussed off-wave rectifier with and without filter. We discussed the importance of the filter in that off-wave rectifier. Here we are going to discuss about filter and what is the need of filter, what is the various types of filter we are going to discuss in this video. Let us discuss need of filters. The output of all these rectifier circuit contains some ripple factor. The ripple factor of your off-wave rectifier is greater than that of full-wave rectifier. The ripple in the signal denotes the presence of some AC component. This AC component has to be completely removed in order to get pure DC output. So yeah, circuit that smoothen the rectified output in a pure DC signal. You can see this diagram. Here we have a rectified output. This rectified output has consists of pulsating DC. This pulsating DC is given to the input of the filter circuit. This filter circuit removes the ripple content present in the pulsating DC and we are getting output as a pure DC output. So how this is going to happen? What are the components are required for this kind of operation? That we are going to discuss here. A filter circuit constructed using two main components. They are nothing but inductor and capacitor. Yeah, inductor allows DC and blocks the AC. Similarly, a capacitor allows AC power and blocks the DC. Types of filters. These filters classified into three categories. One is that capacitor filter, inductor filter, LC filter or pi filter. Capacitor filter. This filter smooths the pulsing DC waveform by connecting one or more capacitor across the rectifier output. As we discussed in the previous off-wave rectifier circuit, the load connected across to the capacitor, so one capacitor is connected across the load, so it removes the ripple content present in the output voltage. Inductor filter. In certain cases, an inductor is combined with the capacitors to create a filter circuit. The inductor serves to smooth out the output by eliminating the ripple content. Next, we are going to see about LC filter, or this is also sometimes called pi filter. This filter circuit uses the properties of inductors and capacitors to effectively eliminate the ripple in the output. Series inductor filter. In this diagram, you can see here we have rectified output voltage as given to the input of the series inductor filter and how we are getting that pure form of DC output voltage. Let us discuss. As inductor allows DC and blocks AC. We seen in the previous slide. A filter called series inductor filter can be constructed by connecting the inductor in series between the rectifier and the load. So the inductor is connected between the load and the rectifier in a series manner. The figure below shows the circuit of the series inductor filter. The rectified output, when passed through this filter, the inductor blocks the AC component that are present in the signal. In order to provide a pure DC, this is a simple primary filter. A shunt capacitor filter. As a capacitor allows AC through it and blocks DC. A filter called shunt capacitor filter can be constructed using a capacitor connected in a shunt. As shown in the following diagram, you can see here the capacitor connected across the load. The rectified output when passed through the filter, AC components present in the signal and grounded through the capacitor, which allows the AC component. The remaining DC components present in the signals are collected at the output. The above filter types discussed are constructed using an inductor or capacitor. Now let us try to both them to make a better filter. If they are combined together. So LC filter. A filter circuit can be constructed using both inductor and capacitor in order to obtain a better output where the efficiency of the inductor and capacitor can be used. The following diagram shows the LC filter. It consists of the inductor and capacitor which are connected in series. Now it's connected parallel to the load. The rectified output when given to the circuit, the inductor allows DC component to pass through it, blocking the AC components in the signal. Now from that signal, few more AC components, if any present, are grounded so that we get the pure DC output. This filter also called the choke input filter, as the input signal first enters the inductor. The output of this filter is better than the previous one. Pi filter. This is another type of filter circuit which is very commonly used. It has a capacitor at its input, and hence it's also called the capacitor input filter. So in the previous slide we have used combination of L and C, but additionally here we are using a two capacitors along with the one inductor. That is mentioned here. Here two capacitor, one inductor is connected in the form of pi-shaped network. A capacitor in a parallel, then an inductor in series, followed by another capacitor in parallel makes this circuit. If needed, several identical sections can also be added to this according to the requirement. This following diagram shows the pi filter. So it consists of the rectified output as an input to this pi filter. Here we have two capacitors and one inductor. It allows the following rectified output. In this circuit, a capacitor in parallel, then an inductor in series, followed by another capacitor in parallel. Capacitor C1 and C2L are connected in as per the circuit diagram. Capacitor C1, this filter capacitor offers high reactant to DC and low reactant to AC signal. After grounding the AC components present in the signal, this signal passes to the inductor for further filtration. Inductor. This inductor offers low reactance to DC components while blocking the AC component if any got managed to pass through the capacitor C1. Capacitor C2, now the signal is further smoothened using this capacitor so that it allows any AC component present in the signal which the inductor has failed to block. Thus gets the desired pure DC output at the load. So advantages of filter circuit in a rectifier. This circuit reduces the pulsating DC output. By using this circuit, electronic device run more efficiently and stable, minimizes or reduces the EMI effect, improves the reliability and performance of the linked devices. Voltage regulation is used some filter circuits to keep the output voltage steady even in the face of variations. So applications of filter circuit in rectifier: used in AC to DC power supply like adapters, used in rectifiers for charging batteries for small electronic devices, used in motor control system to provide the smooth supply, used in telecommunication system, industrial automation system, automotive system as well as. Thank you.